So this is a sine, and as a period of 2 pi, it goes through 0, 0, and it goes through pi and 2 pi. Its domain is all reals. The range is -1 to 1, and it is an odd function. It has an amplitude of A, and A would be a vertical stretch, and it represents the half the height of the wave. The amplitude is the distance from the axis to the maximum values of the function. The frequency is the absolute value of b over 2 pi.
Okay, so how much?
And the period is 2 pi over b.
Okay. That's what this is. So.
Okay, now we're talking about cosecant. So the easiest way to draw cosecant is to graph sine first, and then graph cosecant on the reflection of the sine or the peaks of sine. The asymptotes of cosecant are at 1 over sine x and at the zeros of sine, and the scale is -2 pi to 2 pi. Yeah.
Oh my god, that's a perfect speed. Except it's going to be really, really, really fast. And we're going to finish our video. Yes.
Okay, now we're talking about cosine. So cosine has a shift of pi over 2 from sine, so that means that its period is 2 pi still, and it starts at the peak.
See, there you go. Elton John right there.
Yeah, that's a 2.
And
you're getting absolutely wrecked.
It goes through pi over 2 and 3 pi over 2.
Right, I don't think you can recover. I'm not gonna lie.
The domain is all reals.
Right, you're getting wrecked.
And the range is the same as sine, so it's -1 to 1. And it is an even function. Okay, now we're talking about secant. So the asymptotes of secant are at the zeros of cosine, and secant equals 1 over cosine. So the easiest way to draw secant is to graph cosine and draw it up the peaks. So the zeros are at -pi over 2 and pi over 2 and 3 pi over 2 and -3 pi over 2.
Yeah, but if I'm drawing a line.
Yeah, that's not any square. That's A2 plus B2 equals 4.
No, it's like down here.
And a period is 1 down and 1 up.
I can bring my math to school.
Okay, so now we're doing tangent, and tangent x equals sine x over cosine x, and cosine x cannot equal 0. So where cosine equals 0, there are vertical asymptotes, and where sine equals 0, those are zeros of the function, so they cross the x-axis, and the period of tangent is pi, and the asymptotes are at pi over 2 and 3 pi over 2, and it goes through 0, 0.
Like if you go in the anatomy, it's the first door on the first classroom on the left.
Okay, now we're talking about cotangent. So cotangent x equals cosine x over sine x. So the asymptotes are where sine x equals 0, and the zeros are where cosine x equals 0. So it crosses at -3 pi over 2, -pi over 2, positive pi over 2, and positive 3 pi over 2. and the asymptotes are at 0 and pi, and negative pi. Yeah.
Okay. Okay. You got it? Hold up. Okay, I skipped a lot of steps.
Gather all your strength.
Should I put the Y's? Should I put the X's? Oh, I know what I'm doing. Okay, for transformations of sinusoids, this number in front of any sinusoid just determines the scale. So this one is stretched vertically, so instead of a 1, this is a 3. And then this number determines the period. So for sine x, the period is 2 pi because it's 2 pi over b, which is 1, obviously. It's over here. And then for this one, it'd be 2 pi over 2, which means the period would be pi. So it goes through, this is pi over 2. So this graph looks like this, and you just draw it, and you'll see it's a little bit narrower because it's the period is smaller, so the period is just from 0 to pi instead of 0 to 2 pi. And you could apply this to all other sinusoids just by remembering that this stretches it vertically and then this just changes the period.